So today's lesson is on basically realizing that every number has a decimal equivalent. So we are going to learn how to find the decimal equivalent of rational numbers and how to approximate the decimal equivalent of irrational numbers. So let's look at our first example. The directions say to write each fraction as a decimal. So the first thing that I want you to realize is that when you write fractions as a decimal, you are always going to put the numerator, or the top number, on the inside, and the bottom number, or the denominator, is going to go outside. Okay? So when I look at the fraction 2/5, I'm going to put the number 2 inside, the 5 on the outside, and then I always add a decimal, and I'm just going to throw 2 zeros in there. The first thing that I want you to do is to drive your decimal straight upstairs, because if you don't move it up, you forget about it. Does the number 5 go into 2? No, it doesn't, so I'm going to put a 0 there. Does the number 5 go into 20? Yes, 5 times 4 happens to be 20, and that gives me a remainder of 0. So the fraction 2/5 equals the decimal 0.4. So the fraction 2/5 equals the decimal 0.4. All right, let's look at the fraction 2/9. So 2/9, 2 is going to go on the inside, 9 is going to go on the outside. And again, just like before, I'm going to add a decimal place and put a couple of zeros there, and I'm going to drive my decimal straight upstairs. Does 9 go into 2? No, it does not. Does 9 go into 20? Yes, it does. 9 times 2 is 18. 20, take away 18 is 2. Bring down a 0. Does 9 go into 2 or to 20? Yes, it does. 2 times with 18. Hopefully you can see that this repeats. So the decimal, well, the fraction 2/9 is represented by the decimal 0.2 repeating. That bar over the 2 means that that number is going to go in forever. 0.22222. All right, let's try another one. How about the number 5/7? So let's see. Seven on the outside, 5 on the inside. Put some decimals. Drive my decimal upstairs. Does 7 go into 5? No, it does not. 7 times 6 is 42. 7 times 7 is 49. So 7 will go into 50 7 times with 49. 50 minus 49 is 1. Bring down a 0. Does 7 go into 10? Yes, it does, 1 time with 7. 10 minus 7 is 3. Bring down a 0. Does 7 go into 30? Yes, it does, 4 times with 28. 30 minus 28 is 2. Bring down another 0. Does 7 go into 20? Yes, it does, 2 times with 14. 20 minus 14 is 6. Bring down a 0. Does 7 go into 60? Yes, it does, 8 times with 56. 60 minus 56 is 40. Bring down a 0. Does 7 go into 40? Yes, it does, 5 times. With 35. 40 minus 35 is 5. Bring down a 0. And does 7 go into 50? Yes, it does, 7 times with 49. And you'll see right there, this is exactly what we started with right here. So that is going to repeat. So this is the repeating section. So the decimal 0.714285 with a repeating bar over the entire thing is 5/7. So 5/7 equals 0.714285. 2, 8, 5. All of it repeats. That whole section repeats. So you are going to do 3 over 11 and 13 over 111. I want you to pause the video and go ahead and do those. All right, welcome back. Hopefully you have finished and you discovered that 3 divided by 11 equals 0.27. Repeating that 27, 27, 27 goes on forever. What about the next one? What about 13 divided by 111? Hopefully you discovered that 13 divided by 111 equals 0.117, and that 117 repeats itself. So what did you notice? Well, I noticed that when the denominator equals 9, 7, or 11, the decimal repeats. That's one thing I noticed. I also noticed that when it ends in a 9, you have one digit that repeats. When you have 11 in the denominator, you have 2 digits that repeat. When you have 111 in the denominator, you have 3 digits, although I don't know if that's all the time. Maybe we'll wait on that one. And the 7 has multiple digits that repeat. It really just depends. So next we're going to do this turning a percent into a decimal. Well, the first thing I want to do is turn a percent into a fraction. Remember, a percent is a number over or out of 100. So 5% is the same thing as 5 over 100, which reduces to 1 over 20. Top number goes inside, bottom number goes outside. I'm going to add a decimal and 2 zeros. Does 20 go in the number 1? No, it does not. Does 20 go into the number 10? No, it does not. Does 20 go into the number 100? Yes, it does. So 5% is the same thing as 0.05. What about 28%? Well, that's 28 over 100, which when I divide by 2, turns into 14 over 50. 50 on the outside, 14 on the inside. Add some zeros. Does 50 go into 14? No, it doesn't. Does 50 go into 140? Yes, it does 2 times with 100. Subtract 140 minus 100 is 40. Bring down a 0. Does 50 go into 400? Yes, it does. 8 times. So 28% is the same thing as 0.28. I'm hoping that you're identifying a pattern. I'm hoping that you realize the pattern is that you move the decimal 2 places to the left. So 0.2%, when I move the decimal 2 places to the left, is 1, 2, or the decimal 0.002. All right, let's look at some irrational numbers. So now we're going to look at some radicals. So this first one is the square root of 1, the square root of 1. So the square root of 1 is actually the whole number 1, because 1 times 1 equals 1. The square root of 4 is the whole number 2, and that means that 2 times 2 equals 4. There is no whole number that I can multiply by itself to equal 8, but I can guesstimate, or I can approximate, what is 2.5 times 2.5. So here's where I want you to use a calculator. 2.5 squared is 6.25, so we have to get a little bit bigger than that. So let's try 2.8. What is 2.8 times 2.8? So 2.8, using my decimals calculator, squared is 7.84. What about 2.85? 2.85 squared is 8.12. So what about 2.84? That's 8.06. What about 2.83? I think that's about as close as we're going to get. So using a calculator, I just started plugging in some numbers, and I found out that 2.83 is about the square root of 8. Now, if I had just put in the square root of 8 in a calculator, I would actually get the decimal equivalent of 2.828, which is very close to 2.83. What about the square root of 32? Well, the square root of 32 lies in between 5 squared and 6 squared. So those are the two integers that it lies between. So it's got to be somewhere in between 5 and 6. So I would start with 5.5 and square it. Maybe go to 5.6 and square it. I see that when I put the square root of 32 into a calculator, I find out that the square root of 32 is 5.65. This last one, the square root of 126, I know that lies in between 11 squared and 12 squared. So I'm going to start with 11.3, and I'm going to square it. So 11.3 squared is 127. So that's too much. Let's try 11.2 squared. So 11.2 squared equals 125.4. So let's try 11.25 squared. We're trying to get as close to 126 as we can. So 11.25 squared equals 126.5. So it's probably pretty close to 11.23. Let's try that one. 11.23. What about 11.22? I would say either one of these are a good approximation. 11.23 or 11.22. Notice that for all of these, I rounded to my decimal places to the nearest hundredth. So your assignment is to, for numbers 1 through 10, write the following rational and irrational numbers as decimals. You need to show all of your work just like we've done in our notes. You may use a calculator to check your work. However, you have to show your work, and it has to be done on a separate sheet of paper. When you get here, I want you to make sure that you have at least 2 decimal places. And you tell me the 2 whole numbers that it lies between, just like we did up here, right? We identify the 2 whole numbers that the radical lies between, and then you show me how you broke it down. Started with, if it lies between 11 and 12, break that in half. We'll try 11.2 or 11.3. So you have to show me your options, okay? Alrighty, good luck.